Now we're going to talk about graphing transformations of the sine and cosine graphs. This means that we can do things like vertical stretches or shrinks, vertical and horizontal shifts, and reflections. We're going to start out by talking about vertical stretches and shrinks. To do that, we are going to multiply a number in front of our function. And this one just has sine of x, but we can also do the same thing for cosine of x. If we have a number in front of our cosine or sine function, that gives us a vertical stretch if that number is greater than 1. It shrinks the graph vertically if the number is between 0 and 1. For right now, we're just talking about positive values of a. What this is saying is that these two graphs will have the same shape as sine or cosine, except that the range will be changed. So the range, instead of being from -1 to 1, is going to be from -a to a. Or if our a happened to be negative, then we'd have to take the absolute value. This also gives us the amplitude of the graph. Another way to talk about the amplitude is how far it is from the middle y value to the maximum y value. Let's look at an example of this. If we want to graph y equals 2 sine of x, what this is going to do is it's going to stretch our graph vertically by a factor of 2. If we think about those 5 points that we would have on our basic sine graph, I'm going to plot those 5 points. So I'm going to take my period, which goes from 0 to 2 pi, first I'm going to plot my 5 basic points for just y equals sine of x. So those 5 points were 0, 0. Remember, my sine curve starts at the origin and goes up to a maximum point. So this point is pi over 2, 1. Then it comes back down to the origin. Then it goes down to -1. And then it comes back to the x-axis again. So there's one full period for my graph of y equals sine of x. All this is going to do is it's going to change the y values. It's going to take this and stretch it vertically so that every point that's above the x-axis is twice as far above it. Every point that's below is going to be twice as far below it. It's only going to change the y values of these points. This one, if we take our y value and multiply it by 2, we still get 0, 0. For this one, if we take and multiply our y value by 2, we get 2. So this point is going to become pi over 2, 2. That's going to be our maximum point. For this point, if we multiply 0 by 2, we still get 0. So this point is not going to change. This point we had -1 for a y value. Now we're going to have -2 for a y value. This point, the y value is still going to be 0. What this is going to do to our graph is it's just going to stretch it out and make it look taller. It still has that same curvy kind of shape. It still has the same period, because if we graphed it further on this way, we would get a repeat of exactly what we have here. Now, to find the amplitude of this, well, we can just look at the number that's out in front of this. That would give us an amplitude of 2. How that corresponds to what we have on the graph is if we look at the difference between the highest point and the lowest point. That entire distance between those two is a total of 4 units. Our amplitude is going to be this number divided by 2. So our amplitude, if we looked at the graph, would be that total distance from the maximum value to the minimum value divided by 2. Another way we could think of it would be the distance from the midpoint of the y values, which would be at 0, up to the maximum point, or either that or down to the minimum point. Now the range for this graph, we're looking at the y values. We want to look at the smallest y value and the largest y value. Those are -2 and 2. That gives us our range. In other words, our y values for this graph go from -2 up to +2. They never get smaller than -2, and they never get larger than +2. The next thing we're going to talk about is doing a horizontal stretch or shrink. To get that, instead of multiplying by a number on the outside of our function, we multiply the number on the inside where the x is. That affects our x values, and it gives us a horizontal stretch or horizontal shrink. For horizontal transformations, use the opposite operation in the function as what's actually happening with the x values. In other words, if we want to do a horizontal stretch for this graph, then we want our value inside of here to be between 0 and 1, or we could think of it as dividing by a number. To get a horizontal shrink, we're actually going to multiply, or we can think of it as our b being greater than 1. And this works the same way for the cosine of x. Since this is going to do a horizontal stretch or a shrink, that means that it's going to affect the period of our graph. If we're looking at the graph of y equals sine bx or the cosine of bx with b greater than 0, it's going to have the same basic shape as sine or cosine, but it's going to change the period. It's going to take the original period, which was 2 pi, and divide it by b. So let's look at the equation y equals sine of 2x. And the first thing we're going to do is find the period. Notice there's a big difference in this and when we had the 2 on the outside. If we had the 2 on the outside, that would change the graph vertically. That gave us a vertical stretch. This time, since we've got the 2 on the inside, this is actually going to do a horizontal shrink. What that tells us in general is that the period is going to be smaller because it's going to shrink the period of the graph. We can find what the actual period is by using that little formula. 2 pi over b is going to be our new period. Our b is 2. So this is going to be the period for this particular graph. That means that instead of going through one full cycle between 0 and 2 pi, we'll go through one full cycle of the graph between 0 and pi. Sometimes we list this as an interval. So this would be where we'd have one full cycle or one full period of our graph between 0 and pi. And what we want to do to actually graph this is we want to look at what happens to those 5 key points that we talked about. Now, if we graph our original sine function, we're still going to graph those 5 key points. Since this is sine, it starts at the origin at 0, 0. Then we have the point pi over 2, 1. Then the point pi 0, the point 3 pi over 2, -1. And the point 2 pi 0. There's one full cycle of our basic sine graph. Now what we're doing when we do a horizontal shrink is that we're going to take all these points and move them back this direction towards the y-axis. All we're doing is changing the x values. What we can do is with each one of these x values, we can do the same thing that we did to the period, and that is divide it by 2. So we've got the x values of our 5 key points. If we take and divide each one of these by 2, we get 0, pi over 4, pi over 2, 3 pi over 4, and pi. So what that means is that we're going to go through one full cycle between 0 and pi, just like we were saying up here. So that means that right here is going to be the end of one full cycle of our graph. This is going to be the middle, And then we've got 2 points in between. So here is pi over 4, and this is 3 pi over 4. Our 5 key points are going to be here, 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 and here. It's going to have the same shape, so it starts at 0, 0. It goes up to 1. So our point on this graph will be pi over 4, 1. Then it comes back to the x-axis. Then it goes down to our minimum point with a value of -1, and then it comes back to the x-axis. There's our 5 key points, and then we can just draw our graph through those points. This would be the graph of y equals sine of 2x. Let's do the same thing with a cosine graph. This time our multiplier on the inside with the x is 1/3. If we want to find the period of our new graph, we take 2 pi divided by b, so it's going to be 2 pi divided by 1/3. We can flip this over and multiply. That gives us 2 pi times 3, which would give us a new period of 6 pi. So we're going to complete one full cycle on the interval from 0 to 6 pi. Now let's do the same thing with our 5 key points. We're just talking about affecting the x values here, so I'm only going to write down the x values of the points. We're going to take each one of these x values and do the same thing we did with our period, which was we ended up multiplying it by 3. So if we take each one of these by 3, we get 0, 3 pi over 2, 3 pi. This would be 9 pi over 2 and 6 pi. Let's graph our basic cosine function. I'm going to make this a pretty short graph since we're going to stretch it out a lot. So let's say that 2 pi is right there. Remember, our cosine graph starts up at the maximum point and goes down. That means we would start up here at the point 0, 1. We go down to the x-axis and then down to -1, back up to the x-axis, and back up to 1. This would be one full cycle of our regular cosine graph. Now what we're going to do is take those 5 key points and we're going to stretch them out horizontally so that we start at 0 and we end at 6 pi. So the point in the middle is at 3 pi. Then we've got the point halfway between 0 and 3 pi, which is 3 pi over 2. And then the point halfway between 3 pi and 6 pi would give us 9 pi over 2. That's where our 5 key points are going to be. So the first one is still going to be at 0, 1. That one we didn't change the x value. Then our next one is going to be at 3 pi over 2. For the next one is at 3 pi, and we're going down to -1 on the y-axis. Then we're coming back to the x-axis, and then the last point goes back up to 1. So here's what our graph would look like when we stretch it out this way. That's one full cycle of cosine of 1/3 x.